Hello everybody. Okay, for today's lesson 11.03, expressing partial sums of geometric series recursively, I thought I'd make my own video just to make it a little bit more simple to understand because there's some stuff out there but kind of gets a little cumbersome, and really I just kind of wanted to boil it down to the basics. So I know this is a long title and don't get overwhelmed by it. We're going to break it down piece by piece, so hopefully it's not so overwhelming. Okay, so we have some definitions here. So as we learned from the last video, recursive means applying a rule or formula to its results again and again. We need the previous term in order to decide what the next term is. So one example that we have when something's defined recursively, when we saw in the last video, is you're always given the first term, right? So t sub 1 equals 3. And the definition is t of n equals 2 times t of n minus 1. All right? And you're always given for when n is greater than or equal to 2. All right? So the whole point of this is that we need to know the prior term in order to find the next term. Okay? So if we want to find t sub 2, it would equal 2 times t sub 2 minus 1, which is t sub 1, which is, we know, is 3. So 2 times 3 equals 6. So the second term is going to be 6. So recursive definitions are all about knowing the prior term in order to get the next term. A series. So a series is what you get when adding all or part of the terms of a sequence. Okay, so we have in the prior example, the first two terms were 3, 6, and if we keep multiplying by 2, we have 12. Okay, when we add up the parts of the sequence, that gives us a series. Partial sum, the sum of only some of the sequence. So for example, the first 5 terms or first 8 terms. So if we were taking the partial sum of this sequence up here, okay, we'd have, say, we wanted the sum of the first 3. Okay, this would equal 3 plus 6, which is 9, plus 12 equals 21. That's just a partial sum because we're not taking the sum of all the elements of the series. And finally, a geometric series is a series in which each consecutive term is found using a common ratio. So usually it's seen when, like for example, in this example, the common ratio between each term is 2. If, for example, the sequence went the other way, say it went 12, 6, 3, 1.5, then the ratio would equal 1/2. Since every time we go down, we multiply by 1/2. 12 times 1/2 is 6, times 1/2 is 3, times 1/2 is 1/2. All right, so let's now get into defining things recursively. So let's put it all together. So we need to express the following geometric series recursively. So when we express something recursively, we basically need 3 things. We need to define what the first is, okay? We need to define what the rule is, okay? So what our sum of n is going to equal. And then we need to define what n is going to be. And in this case, we're going to have n is greater than or equal to 2. All right? For this, the sum or the series of part 1 is just going to be 2. All right? And now we need to find out what r is. So as we look at this series, we go from 2 to 8 to 32 to 128. And if you can't see it right away, that's okay, but the ratio here is just 4. So 2 times 4 is 8, 8 times 4 is 32, times 4 is 128. All right, so the ratio here is 4. So in order to define a series recursively, we're going to use the form that goes like this. So the series sub n equals the series or sum of 1 plus r times the sum of n minus 1. So in this case, our s of n is going to be s1, and in this case we know it's 2. So we're going to say 2 plus, our r is 4, times s of n minus 1. We're just going to leave that because that's our recursive term. And that's what we need to know in order to find the sum of the next one. So for example, if we're working on this, if we want to know the sum of the 3 first terms, or the partial sum of the first 3, it's going to equal 2 plus 4 times the sum of 3 minus 1, or that's the sum of 2 in this case, so it would be 2 plus 4 times the sum of 2, and the sum of 2 in this case is 10. All right, so that gives us 2 plus 4 times 10. Order of operations tells us that 4 times 10 is 40, plus 2 is going to give us 42. So that is the sum of the first 3 terms. And we can check that really quick. 32 plus 8 plus 2, sure enough, is 42. And here it is. So our definition, our recursive definition, is right here. These are the 3 elements that you need to define a geometric series recursively.